Hello everyone, welcome to this session. In this session, we are going to discuss a very interesting question from geometry. This question is going to teach you, or let's say make you understand many properties of triangles. Okay, so the question says that in the given figure DE is parallel to BC. So DE parallel BC, DE is 25% of BC. That effectively means that if DE is X or Y, this would be either X 4X or Y 4Y. Okay, that is one of those ideas. Basically, I'm just converting the ratio thing and converting the percentage thing into ratio, right? Now it is given that the area of the triangle AD is 20 square units. Find the area of the sum of the interim triangles. So one thing that I need to understand is that this part is already 20 that is given to me, and I need to find out the other triangles. To solve this question, I need to know a couple of ideas. The first idea is the idea of basic proportionality theorem. I'm just going to quickly revise you what basic proportionality theorem is. Suppose if there are three parallel lines and transversals cutting them. So by the very virtue of these transversals on these parallel lines, you would see that there will be intercept forms. Okay. This is basically your basic proportionality theorem. And when this thing is, let's say when this thing is used up in the cases of triangle, we get something known as a Thales theorem. But please remember, the line that I'm drawing over there needs to be parallel, right? So the triangle ABC and DE has to be parallel. So DE has to be parallel to BC. In that case, we can extend the ideas of the basic proportionality theorem to the triangle. So the idea is that the intercepts will always be in the same ratio. This is the idea of basic proportionality theorem. Okay, I'm not going to write too much. I'm pretty sure you have understood what I'm trying to tell you. The other part is that you need to understand there is a property of similar triangles that helps you compare the areas of two similar triangles. So suppose I'm not proving anything, okay, although this looks more like a samosa, but just for the sake of it, please understand. So ABC and PQR. Not proving it, you can prove it also, but I know it beforehand that ABC is similar to PQR. In that case, area of the triangle ABC to the triangle PQR will be given to you as BC upon QR the whole square. Now these are the sides ka whole square. This is also true for the heights, the in center, the circumcenter, everything. This is one of the properties that you need to remember. So I'm just recalling you this thing. Also one more thing, if you have a, let's say, a triangle like this and there is a CVN that makes an intercept, let's say for this triangle ABC, there is a CVN from the vertex A to D on this triangle such that it creates intercepts in the ratio m is to n. Now if that is the case, if it creates intercept in the ratio m is to n, then the areas will also be in the ratios of m is to n square units. Okay, they won't be like, for example, if this is, let's say, 2 centimeter and 7 centimeter, the area is not going to be 2 square unit and 7 square unit. Could be 2 and 7 also, but then it will be in the ratio 2 is to 7. The areas will be in the ratio. This is one of the ideas. Again, I'm not proving it. You can prove it very easily. So these are the couple of ideas that will be used. Let's solve the first question. In the first question, it is given that this area is already 20 and we need to make sense of the similar triangle. So AD is already similar to ABC. We know this. So if that is the case, area of triangle ADE to the triangle ABC is going to be 1 upon 4 the whole square, that is 1 upon 16. Okay, just by the very virtue of the sides itself. ADE I already know as 20, so ABC straight up comes out as 320. 16 into 20, 320. So the first part becomes very easy. What about the second part? Let's see this. In the second part, we are supposed to find out this area DEB. Okay, this area DEB. Now how do I find this area DEB? Okay, but if you have understood one thing, the okay, now please pay attention. Okay, this is where this might get a little difficult also for some student. I know that this DE is X and BC is 4X. Okay, so if this is X and this one is 4X, what about the other intercepts AE is to EC? Please don't make the mistake as calling them as x by 4x. Basically these are sides of the D is the side of a smaller triangle and BC is the side of the bigger triangle. So this is not going to be 4x. EC is not 4x. The entire length AC will be in the ratio of 4x, or you can also say 1:4 the ratio. In that case this is 3x. You can call it 3y also, I don't mind. Okay, rather I should call it like this only, y3y. Okay, now if you know that this entire thing is y3y, have I not discussed right now that when a triangle is there, let me highlight the triangle. So this triangle has a CVN. Now which is the CVN? This is the CVN. Okay, I hope you can see that this is a CVN. So the area will also get distributed in the same ratio, 3:1 or 1:3, whatever you want to call it. Do I know the entire area? Yes, it is 320, and the basically 4 parts. Now 4 parts corresponds to 320, 1 part shall correspond to 80, and 3 parts shall correspond to 240. That means I know that this part which is DBC is 240 and ADC is 80. Hold on, if I know that ADC is 80, this entire part is 80, of which this much is 20, is this not understandable that this part has to be 60? Okay, so if this is 60, the other part which is obviously going to be 60 because it's a regular figure and everything seems to be the equal, so the DEF as well as DEC equals to 60 square units is the area of this part. Okay, I hope that made sense. Now we have been able to solve these 2 questions very effectively. Now what about D? Alright guys, now we will be finding the area of this part DEF. For that we have to be a little cautious. Okay, in this triangle, because this is the only triangle that is with no intercepts, nothing like that given, so we need to make some sense. So because we are into considering the triangle DEF and the next triangle is BFC, let's take both of them simultaneously. Now let's try to understand what exactly I'm trying to tell you. Basically these 2 triangles are obviously similar for many reasons. Vertically opposite angle, this angle and this angle, so all the 3 angles are equal, so they are similar in fact. So what is it that I'm trying to tell you? That the sides are always going to be in the same ratio, which effectively means, please pay attention, if I say that DE upon BC for the 2 small triangle, the ratio is going to be equal to EF upon FB, that is going to be equal to DF upon CF. All of this is equals to 1/4. This is by the very theory. So what did I say? That DF upon CF, that is this is 1:4, this is also 1:4. I hope that made sense. Now let's see what is it that we can find out. Do we know the area of DEB? Think about it. Do we know the area of DEB? I am highlighting this area so that it becomes easier for you. Just now we calculated that the area of DEB is 60. Hello. So if this is 60 and we know that the intercepts, please look at this thing carefully, the same idea, CVN and that thing, 1:4 the ratio. So if 5 part corresponds to 60, 1 part shall corresponds to 12, so this is 12 now. Okay, so you have to have this much idea. So if I know that this is 12, this is 20, obviously now I can find out these 2 areas, which is how much? 80 minus 60 minus 12. 60 minus 12 is how much? 48. And this part will also be 48. Now to find out BFC, all you can do is you can just add all the numbers and you can subtract from 320, or you can do something else, which is, if I know this area, and because again DEF and BFC are also similar, so if these are also similar, so I can use the property of similar triangle, that area of DEF upon area of BFC will be, again understand, that is 1/4 the whole square. that is 1 upon 16. I already know that the area of DEF is 12, so BFC comes out as 16 into 12. We can do this quickly, right? So 12, 2 ones are 2, 8, 9, 192, right? So 192 has to be the area of this part. Now let's quickly do the subtraction business. So this is 20, 32, 32 plus 96. 128, 320 minus 128. This is 10 minus 8 is 2, 11 minus 2 is 9, and 192. Both are same. So you can basically find individual areas and subtract, or you can use the ideas of similarity of triangles. You will get the same answer. I hope that answers your doubt.